Good night, guys.
Right.
Night.
Oh, everybody finding the Edicasoft.
I'm still learning to use it.
But remember me
doing-
telling you, please log in and do the work, because what had reached me the last time was that time run out on me, and it's a lot say better we go on.
Yeah.
Practice little by little. Me know say rough like a night time. Log in, do local practice and whatever, and ensure say we are do the homework and the quiz, which is what is graded.
So
Yeah, I was
Utterly, is the homework and the quiz, is that time, do we get a time to do it when you start?
Well, when I did it, there was no time.
It's
Oh,
not
okay,
time.
that is what I want to know.
No, it's not
So-
time.
So you can't I realize that you can't access it if you don't go through the work itself.
No, the thing is you still need to read the required information.
Go through the tutorials.
Yes.
You have to do the tutorial first. If you don't do the tutorial, I can't move through. And
That's what
pay keen attention to the tutorial, because those are the questions that you're going to be getting similar questions. And it's just a one attempt for the homework. So we have to try and make sure that we do the practices. The practices are actually 45 questions, guys. 45 for one. And
For
when
what?
you go in an Edicasoft, so because of 5, for Edicasoft, it's 5 of 5 attempts that you have, which means you can get to go through, and each of them is 15 questions. So
That part. Yeah, it's
yeah,
cool.
so you can get to go through and get familiarized with it, and then after
Yeah,
you do
man,
it,
I go through
I know I'm
them.
gonna do my practices first. So do the practices first, but when me tell you say it's a lot of work, because if you check all the practices, how much question, and it's like how much unit, it's like 18.
Yeah, because I was going through one today.
Yes.
But I
So
went
it is
through 3, so I just have one more to go through to do, so I can do one of the tests or the quiz or the homework. But I'm telling you, I'm trying to go through it today, and it's a lot. I'm not reaching nowhere yet.
yeah, it's rough. I mean, I tell you, because I'm behind too, but me just encourage you, because I wouldn't want to reach me enemy. So guys, please, me could read, me could put, if I have 1 hour night time, I know say we're tired to a whole away up whole thing. Me could just go and, put in some work.
Thanks for the advice.
Yeah, man.
Yes, thanks for
Thank you, Ottilie. I listened to you. Out of the horse's mouth, he who feels it knows it. And there's nothing more I can say to it other than I felt very disappointed today when I logged on to Edico, and matter of fact, they are, I should just name and shame people, but anyhow, quite a number of students in the class that have not yet started, have not even started one piece of assignment. And I'm not one of those lecturers who will say, sure, I feel them business. I'm going to give you yet another opportunity. You see, after that, students, once I start close up my assessments, nobody can ask me to reopen those, and you're going to be getting zeros for those. Anybody knows what week we're in?
What week we're in?
Yeah.
Week 7.
Thank you very much. Thank you very much. More than half the semester, and I have people in the class who have not even started in one piece of work. And I'm happy that Arthur has spoken. I'm happy because I have nothing more to say. I have nothing more to say. I see 1 or 2 people moving, not as fast as I want you to move because I'm way ahead of you. in the stuff, but what to do?
When you say we're ahead, sir, how many units ahead of us are you?
I'm not logged in Crossword to check. I don't want to speak give you incorrect data. But
because some of us are at uni for right now, so I just want to know.
Yeah, I didn't say all of, quite a number. More than half the class don't start it,
Wait, what?
Okay. That's the point I'm trying to make. More than half the class have not started anything on Edico. I mean, if you want, I can project it if you think that I'm lying and throw name and shame some people.
No, that's not.
I'm gonna give you one more chance. And this is what is gonna happen. If I don't see any activity moving over this weekend, I'm gonna close them out. And I'm sorry. Guess what? There comes a point. Let me just say this. There's no love lost, but let me just say it. So when I was going to the university, I would see one of my lecturers along the corridor, and I'll engage my lecturer in a wonderful conversation, if them have the time, knowing very well that the lecturer is going to my class, and I don't turn up. You think so that lecturer business? Or the lecturer even notice that I don't turn up? The lecturer is going to go to the class and teach. But at the end of the semester, the exam will come. But hear me now, and that is andragogy, adult learning. And hear me now, teaching in a tertiary institution when I'm supposed to be practicing andragogy. Still doing the secondary form of teaching, the pedagogy. Students, do your work. Come on, students, you're not doing well. I gave it 2 questions. Last week, Thursday. I don't want them again, I'm gonna give 2 questions last week, Thursday, and it's one student. One nigga student sent me something today to say, sir, look at this for me. One student.
Say you don't want the
No, sir, I'm not looking at that, sir. I'm moving straight ahead.
Sir, I didn't know we were supposed to send them to you because I did them and I told you last class, but I didn't know we were supposed to send them.
Yeah, man, we had unless I don't remember what it is that I said. Last class, I'm almost sure that I said, I am not doing those questions, and those of you who have done the questions to send them via WhatsApp, and I will look at it, but I refuse to do it. Did I say that? I don't remember.
Oh, say if we send them to you, you'll accept them? Is that what you're saying? Because I wrote them down,
No. I said yours. Did I say that? Tell me if I'm. Sometimes I don't remember the things that I say now.
Did I say that? When I said that I attempted, you said I should send it to you.
Okay.
Sir, so should I still send it to you? Because I did it from last week, but from the time when you sent it in the group, but I just never sent it to you.
All right, let me pray about it, Miss Kates. I pray about it.
Sir, you did say it, at the end, at the start of the class, because I think somebody else along myself said we didn't see it. Did it work on it, but didn't remember that you said that we should actually send it to you.
Yeah, fair enough. So put it this way. So when I give instructions like this, and I could have said it in the WhatsApp group, and I received that one from that lonesome student. I could have said, students, send me the work. And I said, no, I'm not going to say anything because we have to take the responsibility. There is no love lost, but we just show you a little trips, because if me ever come a class and don't prepare one day or something happen, me know say. But in fact, I don't even know if it is happening yet. One of the first one I got email, Mrs. Campbell, Mr. Shandy is not doing this, and Mr. Shandy is not doing that, and Mr. Shandy is not sending the recordings, and Mr. Shandy is not coming to class, and Mr. Shandy is late, and Mr. Shandy is this, and Mr. Shandy. But I bet you say none of them email her and say, Mrs. Campbell, you know what? Mr. Shandy gave us work. I know, so we don't do it. But we'll do it for Miss Campbell. We not do nothing. Life is unfair. It is unfair. So unfair. But anyhow,
Mr.
it is
Mark.
a good thing. Go ahead.
No. I forgot. I forgot what I wanted to ask you. I'll try asking again later.
No problem. There's no love lost in it.
Sir,
Yes, go ahead, please, Doris.
it's my first time using Edicasoft, so I'm trying to
No,
learn.
that's all right. Guess
Right.
what? You have so many students in here that have used it before. So if you have any difficulty, drop it in the group. If they can't answer you, I'll answer you. Or just drop it in the group. Remember,
Okay.
that's one of the things again, we have the WhatsApp group, Any difficulty you have, man, just drop it in there. There are so many students in the class here that have used Edicosoft before. And if they can't answer you, I would be more than happy to answer. So just drop the concerns in the group. All right. With that said, I trust that you had a good day, and I trust that you are ready to be working with me. This is where the book starts. Big school differentiation. We're going to be doing some DJs tonight, and I was know who can sing from who can't sing. And I'm just really looking forward to what should happen. But anyhow, the final thing before I move on, because I'm happy to say it. If you guys continue, in the vein that you're going, the Mr. Nice Guy is going to be gone. And what is going to be left is the silhouette of somebody that you're not going to like. If you continue in the same vein, a lazy, and not show no interest, and not going like on a special, and this and that, at some point in time, the Mr. Nice Guy is going to go, and it's just my silhouette that you will find. You may not like the silhouette. You may not like the silhouette. And based on the energies that I'm getting from you guys already, trust me, I may suggest very strongly that somebody else take you guys up for the calculus too. Real talk. I don't think I would really want to put myself through all of this for whole of one academic year. All right? So we have many people who can teach the course. Students, I full of money, but I can't take the stance to say, I don't care, I'm going to come to class and teach. I have to say my prayers before I go to bed at night time. I have to say to my wake up, I have to go to church. I have to pray, I have to throw my tithes. And Father God will beat me up. So I can't do it. But there will come a time when I stop talking. Real talk. That I can say, you know what? Father, I have done my best. All right, let's go. 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 All right. Sorry, I was just reading the chat, and let me just say it. I'm going to say it. I once did evening school when I finished my degree. I went back to school in the evening. So I know exactly what you guys are going through. When you reach a yard, you don't want to see no book, you just want, matter of fact, you don't even want to be here, you just want to go to the bed. Me know the talk. Me know. All the time me drop asleep with food in my mouth, I try eat and drop asleep on the table or in the settee I eat. All the time. But when you look at it, you say that you reach too far, finish the associate, and you're almost into one semester of the bachelor's, you can't give up now. You pay some money already, pay enough money already. You have to commit to the task, work out something. Let me tell you what I did. Because I know when I came home from school, yeah, Excelsior School, I would have been tired. Because most time I also teach evening school. Evening school done 9 o'clock. On the days when I don't go to school. I would go home, I would freshen up, and I'm gonna have something heavy or something light. Then I got chuck off and sleep. And religiously, I would get up, say 2 o'clock, 3 o'clock, and try getting about 3 hours work. If I get up at 3 o'clock, I'm gonna work from 3 o'clock right back to 6 o'clock. When 6 o'clock come, and if I feel tired like I want to go sleep, I say, here the plan, at 4:30 or 5 o'clock. And I go to bathroom, go bed. Me go to bathroom, go bed, watch what the sleep out of my eye and just do the stuff. You spend the semester done, me kill sleep. Me kill it. And when the weekend come, me catch up on my missing sleep. But some of you are not putting in the work, period. Nothing is being done, period. That's the one that I have a problem with. But
Sorry, sir.
let's go. All right, so we're on to differentiation. We looked at several notations. We looked at f of x, we looked at y. If we're finding the first derivative of f of x, it's going to become f dash of x. The second derivative is going to be f double dash of x. If we're using a y notation, sorry?
Sorry to cut you, sir, but I have no idea what you mean because I wasn't at class last Tuesday. Sorry.
Yeah, but kind of post the recording still. You got a chance to look at the recording?
No, sir.
Yeah, man, the recording is there. So when we don't come to class, try make sure you go to the recording so you can look at what was done. All right, so I'm doing a quick revision of what was done, nonetheless. Oh, and that's another thing. When I look at the stuff, it tells me the analytics of it. And there's a class of 20 odd students, and sometimes only 3 views. And life funny, you know. Life is so funny. Because if I don't post the recordings, I'm gonna complain. And I post the recordings, 3 students. Sometimes the recording goes and no views. But it's life. So if I'm using no f of x notation, the first derivative is going to be f dash of x, it's on the board. The second derivative is going to be f double dash of x. If I'm using y as a notation, the first derivative is going to be denoted as dy by dx. And the second derivative is d squared y by dx squared. We looked at an example. Y is equals to x to the third power. Recognizing that when I'm differentiating y is equal to f to the n, dy by dx is going to be equal to n x to the n minus 1. Dy by dx is going to be equal to n x to the n minus 1. Sir, where do you get that from? That n in the power, the n in the power is going to be multiplying the coefficient of the variable. In this case, x. The number in front of x here is a 1, so 1 times x is x. So that's why I've seen an x there by dy by dx. And then I'm going to reduce the power by 1. So it means that I'm going to subtract 1 from the power. So y is equal to x to the n dy by dx is going to be equal to nx to the n minus 1. So if you look at example 1, you'll see y is equal to x cubed. Y is equal to x cubed. Dy by dx in this case, this 3 is going to be used to multiply the coefficient of x. And again, that's 1. So 3 ones will be 3. So I'm going to have 3x. But remember that I'm reducing the power by 1.
So you have to subtract 1 from 3.
So I'm going to subtract 1 from the power, so it becomes to the second power. So my answer there is going to be 3x to the second power. Right there. So dy by dx is equal to 3x to the second power. Any questions so far?
No, sir.
Sir, can you go over this again, please?
Let me annotate.
All right, so I guess I should ask this from now, sir.
Yeah.
In whatever base power that's used, you always use it to multiply the coefficient, which in this simple case will always be 1, but you have to reduce the power of the coefficient, the power of the power itself. So you have to subtract that from whatever using. All right, all right. Say in this case, x to the power x to the increased power was 4, and you multiplied 4 by the coefficient, you'd have 4x. But then you'd have to reduce the power, so then it would be 4 minus 1. Huh?
Yes, Professor. Yeah.
Yeah.
You said something about base though that I'm trying to wrap my head on. What base you talking about?
No, I made a mistake because base.
Okay. All right. No. Don't go no further. Don't go no further. If it's a mistake and it's a mistake, I don't want you to say what the mistake is. There's somebody else will hear it, because I hear it and I was, where did you get that from? But yeah. So leave that alone. But yes, you're correct. So if you had x to the 4th, it's going to be 4x squared, 4x cubed. Yeah. Because remember, it's y equals x to the n. It's going to become nx to the n minus 1. So you use a power to multiply the coefficient and reduce the power by 1. Use a power to multiply the coefficient and reduce the power by 1 every single time. Every single time. All righty. All right. We have a lot to get through today now. I need to make up some time because I have been spending some time to build your confidence and to talk with you. So I have to make up some time today. All right. So these are questions that we've done in class last week. On Tuesday. And I'm just doing a review of what it is that we did. So example 2 asks us to differentiate y is equal to negative 3x squared minus 2x minus 3. The same principle takes place. One of the things you'll see me do is to rewrite the question. So every time you have to rewrite the question, no, only because I'm teaching you why I'm doing it. So I rewrite the question. Negative 3x squared, I put it back, but the negative 2x, I put negative 2x to the first power. And I color coded to show you that by I put it into the first power. Why, sir? I want you to recognize at this point that when it is that you're not seeing an index, a power, or an exponent, you can assume that it is 1. Negative 1, sir, positive 1. Then, sir, what if it is negative 1? Then they will have to write it as negative 1. But if you're only seeing 3x, it is going to be 3x to the first power. 10x, 10x to the first power. Negative 2x, negative 2x to the first power. If the power is anything other than 1, they will have to write it. And then one of the things that I want you to understand also is that when you have a constant, that constant is going to be 3x to the 0. Why, sir? Because anything raised to the power 0 is 1. So when I put x to the 0 in green, it is not changing the value of x, of 3. It is not changing the value of 3 because x raised to the 0 is going to be equal to 1. And 1 times 3 is 3. And there's a reason I do that. There's a reason I do that. There's a reason I do that. Because there are reasons for me doing that. Reason number 1 is to say to you, anything raised to the power 0 is equals to 1. And reason number 2 the differential of a constant is always equals to 0 for the first reason. So reason number 1 is that you have x to the 0 and anything raised to the power 0 is 1. Now, if you follow the same line of argument, I'm going to be using my power, my index, my exponent to multiply the coefficient. The power is 0. 0 times anything is 0. So the differential of a constant always equals 0. The differential of a constant always equal to 0. The differential of a constant always equals to 0. All right? Go ahead, please.
Just try for button in. But sir, why you put back the X? Understand
What
this,
X?
Sorry, the X right we have in green there, so.
Oh, I just put it there to show, you know, because
Yeah,
this,
just put it there.
yeah. So at some point in time, I don't want to see nobody doing a rewriting of the stuff, you know. I'm only rewriting it because I'm teaching you.
Okay, sir.
You know, Leon, mommy and daddy buys you, or maybe you buy your own children a bicycle, and they say, "Oh no, me not go drop off of this and match up my good cute face. Say buy some training wheels." But after a while, the training wheels don't make no sense. And I'm going to tell you something that I recognize, and this is some psychology. I remember seeing a youngster with the training wheels, and it so happened that the training wheels bent, you know, bent. And when the child was riding, the training wheels not touching the ground at all. Not touching the ground at all. And I remember I suggested, let us remove the training wheels. No, I'm going to fall off the bicycle. But the child didn't even recognize that while they were riding, the training wheels were not touching the ground at all, and that they were riding on their own. You know, just like when teacher, you can't do the question if teacher not around you because you don't have that confidence. Yeah, the point is, once you've built that confidence, I expect you to move from the question directly to the answer, because you can work out something them into your head, and which is why we're getting DJ in class tonight. Because every time you do the question, you go bust a tune. You go bust a tune. Nobody teaches differentiation like this, like me, in the college. Everybody do the traditional way. I found a different way to teach it. All right? So let's go. Watch me now. The same concept. I'm using the 2 to multiply the coefficient of x. So 2 times -3 is -6. So this becomes -6x because I'm reducing the power by 1. And then 1 times -2 is -2. And I'm reducing the power by 1. And the differential of a constant is going to be equal to 0 every single time. The differential of a constant equals 0. Yesterday, today, and forever, it will be equal to 0. So my final answer is going to be -6x to the first power, but I don't have to write to the first power. Once it is to the first power and to the first power alone, I don't have to write to the first. I just write -6x. -6x. And this one is going to be -2. Sir, no, -2 to the 0. Anything raised to the power 0 is 1. So x to the 0 is going to be 1. 1 minus 1 is 0. Anything raised to the power 0 is 1. So x to the 0 is 1, and 1 times -2 is -2. So my final answer is going to be -6x minus 2.
Sir,
Go ahead.
can you explain where you get the -2x again?
Can you just explain all of the second part, please?
-2x is right here. I don't understand what I mean. -2x. -2x is right here. What do you mean? Oh, I get -2x. -2x was a question given.
Okay, sir.
No, play with me. You said, okay, what that mean?
Sir, you said -2 times -3 is -6. So if the -6 is there, why did the -2 repeat back itself?
You know, repeat it, multiply by the 1, but you have to get back the same thing, the power of 1.
Okay.
All right. Thank you, Lottie.
So
Shanti, you see it now, Shanti? Huh?
Yes, sir.
All right. See, you see, I'm telling you, don't play with me because you say, okay, sir, but you still didn't see what it is. Your question wasn't answered. So if when you ask me a question and it no answer, no tell me, okay, sir. Tell me, say, sir, me still not get it. Tell me why you get it. All right, but let me ask you now, Shantia. You get it now, right, hon?
Yes, I do, sir.
All right, good. All right, so let me go again. Miss Joe, you have to go watch the recording there now because I have to move. I can't be going back over the stuff, so you have to go watch the recording in a quick time. So
So I
watch out the
just
sleep.
want to know how
Yeah,
you got the -6.
watch out the sleep out of your eye and come quick and fast. I can't go back on that. I'm not going to finish the syllabus. Let's go. So I have -3x squared minus 2x minus 3. Negative 2 times -3 is going to be -6. So the -6 right here. So boom. And then I'm reducing this by 1. So it's going to be 2 minus 1. See it so? 2 minus 1 are going to be 1. See it here is x to the first power. X to the first power is x. We not have to write to the first power. All right? And let's go. Minus 2x is the same thing as minus 2x raised to the first power. See it right here, sir? To be minus 2x. This minus 2x is going to be the same thing as minus 2x raised to the first power. And this is going to be 1 times -2 is going to be -2. See it right here, sir? -2. And then I'm subtracting 1 from the power. 1 minus 1 is 0. See it right here, sir? X to the 1 minus 1 are 0. But it says, recall, anything raised to the power 0 equal 1 every single time. So the x to the 0 are 1, and 1 times -2 are -2. And the differential of a constant is always equal to 0. So this -3 can magically go to 0. So at some point in time, all of them is sitting in the so. Me not going to see you do it because we're going to move from here so directly to here so. From question directly to answer. All right? Example 3. All of this we went through last class. Example 3.
Sir?
Go ahead, Papa.
Good evening. So that means we don't even have to write the steps in answering a differential question. Is that what you mean?
Absolutely.
Oh, that's good. Okay.
But make sure to say where you write correct.
Yes, sir.
All right, let's go. Why did I write this 2 times? Just to show you that the question says differentiate 4x squared plus 3x minus 1. That's an expression. That's an expression. And you first have to name the stuff. I'm sure, who can I trouble? I'm sure if I say to Azra or Ashantia or Sharifa or Keandra or Lottie, you girl, will not go answer because I disrespect you no have a name. Right? And even some of the youth them. Sometimes them get offended when they say, yo, king, or yo, dog. Oh Lord, forgive me, Jesus. I hate that term. You know, so we have a name.
What?
And we want to be called that name. We want to be identified by her birth name. So does my equation. It needs to be identified by a name. Any name you want to call it, but call it one name. So in the first example of example 3, in the first solution of example 3, I gave the question differentiate 4x squared plus 3x minus 1. And you'll recognize that both questions are exactly the same. But in one instant, I said, let f of x, and me a name it, you know. I get one name. So let f of x be equals to the function 4x squared plus 3x minus 1. But somebody else may say, I don't want f of x, I want h of x. So let it is the same thing. So when the person uses f of x, the answer is going to be f dash of x, and then we're going to do the integration, the differentiation. And if the person uses h of x, it's going to be h dash of x. And if you look at both of them in red, you recognize that I get the same answer, 8x plus 3. Now we're going to check to see if 8x plus 3 is what it is, that is the correct answer. So it doesn't matter if somebody name it, you just can't call it x of x. But if somebody want to call it z of x, and somebody want to call it pi of x, and somebody want to call it alpha of x, it doesn't matter how you name it, but you have to name it. Because it can't go ahead mathematically to just differentiate something and say dy by dx is equal to this, when in fact, this function has no name. My math teacher, may her soul rest in peace, will penalize you for that.
Sir,
Will penalize you for that.
a question.
Go ahead.
I realize I see that little single quote beside of the F. So is it that when we're finishing writing our answer, we should always have that little single quote a part of it? Or
Wait, talk about that. Look at something, Professor.
yes, sir.
Yeah. I'd have to go tell you the first derivative, you know.
Oh, okay.
Yeah.
That's what it's for. Okay.
Yeah. So f dash of x and h dash of x is telling you that I'm in my first differential.
Oh,
because I can ask you to differentiate it a second time, and then it becomes f double dash of x.
Okay, second.
Or h double dash of x, yeah.
Okay. All right. Thank you, sir.
Good. Happy you asked that question, because what I'm trying to build on now is something that we have to go use, because at some point in time I have to find a second derivative. When I'm moving to stationary points, in order to classify those points, we'll have to find a second derivative. And as a result of that, you have to be able to name the function, because if you don't name it, I don't know what it is, and I'm not supposed to assume that this is what you meant, and you're going to be penalized. All right, we don't want that, so we need to clear it up. All right, let's go. 2 times 4 is 8. See the 8 here, and I'm reducing this by 1. 2 minus 1 is 1. X to the first power is the same thing as x, so it becomes 8x. X is raised to the first power in this case, so 1 times 3 is 3. See this 3 here, and because this is 1 and I reduce it by 1, 1 minus 1 is 0. Anything raised to the power 0 is 1, so it's just 1. So it's going to be 1 times positive 3, which is positive 3. And the differential of a constant is equal to 0 every single time. So the differential of -1 is 0. And the same thing happens here. It's the same function. The only thing I was doing here is to show you that I can call it anything different, right? And I end up with the same answer. Any quick questions so far?
All right, sir.
Sir,
Yes, I have a question.
Go ahead.
All right, you go ahead.
All right, sir. So if we have 8x to the power 1, we would same way. Not gonna be penalized for it.
I wouldn't. Because when you get a little bit more mature, you're gonna realize you don't need to write it once. I really wouldn't penalize you. And if you write it in 2 steps or 3 steps, no, I won't penalize you. But I will guarantee you, when you get mature in doing the question, you will recognize that you don't have to write 8x to the first. You just go ahead and just write 8x. I wouldn't penalize you. Shanti, I saw you're about to unmute. You're going to ask a question? Shanti?
Yeah.
Go ahead, hon.
Sir, I said no.
Oh, okay. Sorry. All right, let's go. Let's go.
Suppose you have 4x plus 3x minus 1, or that's not possible.
No, because I mean, if you have 4x plus 3x, you can add a 4x to the 3x to get 7x.
Okay.
Yeah. All
Sir,
right.
I have a concern.
What concern you have, Pops?
Okay, so basically you have said that, you know, the functions that you have at the 2 sides here, it's the same thing in terms of the expression, but it's in terms of the name, it's completely different. So that makes the whole thing different. So I was asking if, you know, those two are different and not the same.
Same answer.
So sir, then H2 double stroke X equal whatever is, it would be equal to F double stroke X equal to whatever for the second derivative.
Absolutely. And d squared y by dx squared would have been equal to the same thing. Absolutely.
Sir, going off of that,
no,
sir.
hold on, Crosswell. Dan, you get what I'm saying?
Yes, sir. You're saying that it would be equal in all cases because it's the same expression.
Yeah, every single case it will be the same thing. It's just that, put it this way, Dan. Some people cook them rice and peas and put little sugar in it. No, only put sugar to make it sweet, you know. Them just put little sugar in it for just maybe bring out the coconut milk, I guess. But guess what? I don't cook like that. I don't put no sugar in a pot. Some people cook them curry and then decide I'm gonna burn them curry first before them do it. I don't do that. But guess what? My curry nice. And someone may say, no, the curry cook best when they burn it. And to each his own. But at the end of the day, what do I have? I still have rice and peas and I still have curry. Funny story. Before we had that boom, maybe only did a little bit still, or in high school, some of you, when BlackBerry was, if you never had a BlackBerry, you never had a phone. So before, huh?
Yeah, that would have probably done a primary school in time there.
Yeah, man. You know, be quiet, boy. Don't call me old. But anyhow, so I had a BlackBerry, but my BlackBerry had a trackball to the side. So when I had my BlackBerry and I came to school and my students said, sir, what kind of phone that? And I said, it's a BlackBerry. Them said, Black what, sir? Sir, we don't have a phone there. Where you come from, sir? China? I said, no, came out of Canada. It was a BlackBerry. It's a business type phone. And I said, okay. And then BlackBerry licked the market. And so when BlackBerry licked the market and the BlackBerry curve come out and everything, students used to laugh at my phone and say my phone is old because the trackball is not in the center of the phone. It is to the side. I mean, I have to turn it like one dialer. I mean, I do the stuff. And he used to laugh at me. I said, guess what? Is it still a BlackBerry? Does it say BlackBerry on it? Them say, sir, but you're one big. I said, I don't care. It's still a phone. It's still a BlackBerry. Right? So whether or not you have an X6 or one series, you still have a BMW. Point is, if you name it F dash of X or H dash of X or dy by dx, it gives you the same result. Same result. All right? And your F double dash of X will also be equals to your H double dash of X once you do the question correctly. And it will also be equals to d squared y by dx squared. All right? I know you guys are anxious, that's why you're asking some of these questions, but don't worry about it. Let's go. Example 4 said to differentiate g of x is equals to 1 over x to the 7th plus 3 over x to the 5th minus 4x squared minus 6. And of them things I'm gonna like, you know, because teacher always teach with one something and then them have to just come, boom, lick with something else that you don't say. And I said, that's fine. That's perfectly fine. They did it to me, so I do it to you. And then when you start teaching your children and start teach somebody else or kind of teaching job, you can end up doing the same thing. It's just adding a little bit of flavor to it. Just a little bit more flavor to the stuff. All right? So it's a little extra seasoning. The seasoning going in the pot already. I'm going to put a little bit poops more so we can just re-flavor the pot. So remember, recall, 1 over a to the m is going to be equals to a to the negative m. See, Tessa? 1 over a to the m is going to be equals to a to the negative m. You're finding the reciprocal of that. And if you're finding the reciprocal of 1 over a to the negative m, it's going to become a to the positive m.
Wait.
It's going to become a to the positive m.
Okay.
So 1 over x to the 7th, because the 7 is positive in the denominator. When you raise that term to the numerator, it becomes x to the negative 7. And the point I was trying to bring across there in that particular question is to show you that it doesn't have to be 1 alone in the numerator. It could be any number in the numerator. So 3 over x to the 5 or to the 5th power is going to be 3 times x to the negative 5. 3 times x to the negative 5. So it doesn't matter what it is that you're doing, the concept is just going to be the same. You have a number in the denominator, raised up power. that power is going to be the negative or the positive. You're going to reciprocate it. If it is negative in the denominator, it becomes positive in the numerator. If it is positive down here, it becomes negative up top. Let's go. So my 1 over x to the 7th is going to become x to the negative 7. And my 3 over x to the 5th becomes x3 times x to the negative 5. And of course, I'll write back my negative 4x squared minus 6. The same concept is carried forward. What's that concept, sir? Y is equals to x to the n. dy by dx is going to be equals to n x to the n minus 1. I'm subtracting 1 from the power. I'm subtracting 1 from the power. You always use the power to multiply the coefficient, and you reduce the power by 1. That's very important, you know. Very important, because when I move to integration, I'm going to still make reference to that power, but it's going to be something else to the power. All right? So what we're going to be doing is to say negative 7 times 1 is negative 7. I am reducing the power by 1. So minus 7 minus 1 is not minus 6, it is minus 8. And negative 5 times 3 is going to be negative 15. And remember, when I subtract from a negative number, I am in more debt. So it becomes negative 6. What will change now? 2 times negative 4 is negative 8.
Sir,
Yes, please.
sir, when you get a negative 6, how you got negative 6 again?
Negative 6. Negative 6 was always there.
No, I subtract 1 from
No,
Yeah,
Cresswell.
one.
Negative 5.
Negative
take away.
5 minus 1, the n minus 1 will cut up on there.
negative
Okay,
5 minus 1. I always reduce. I always reduce. The power by 1. I'm free to copy anything from this computer because it's going to tell me that it's not responding. Oh, come on, system, just behave like a good little church boy. Oh, Lord. All right. Y is equal to x to the n. It's going to be n x to the n minus 1. So I'm reducing the power by 1. But if n is negative, it's going to seem as if you're increasing, because it's not increasing. It's really a decrease because it's a negative value. This minus 5 minus 1 becomes minus 6. And of course, 2 times negative 4 is going to be negative 8. And you're reducing it by 1. So it becomes negative 8x. And the differential of a constant is equal to 0. So negative 6, when I differentiate negative 6, I get 0. The differential of a constant is equal to 0. All right? So that's what we looked at in class last time around. And I have a little bit of exercise here for you, but let us just check this one to see if the answer is really 14x minus 3. I was tired, I guess, when I did this. I'm not sure. Let's go. So I'm saying to you that y, this function is already named, so I don't need to name it. When the function is not named, I have to name it. This one is already named. So y is equal to x squared. So oh, Lord, forgive me. Y is equal to 7x squared minus 3x minus 6. So dy by dx is going to be equal to, watch me, 2 times 7 is 14. See it here, so x to the 2 minus 1 is x to the first, which is the same thing as x. Boom. And when I differentiate negative 3x, I'm going to get negative 3. Boom. The differential of a constant is equal to 0. Quick and fast. Am I correct?
With what you see, with what you shown us.
In the red writing, sir?
Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
With,
Yes, sir.
with what you've shown us for, yeah.
What's the answer for that?
So that'll.
So it's 4x.
4
plus
4x,
5.
Plus 5.
4x plus 5.
4x plus 5.
Very good. Excellent. But incidentally, on the wrong. No, everyone on the wrong. What's the answer?
Sir, if
F of
Oh, the F. F with that, sorry.
F dash of X.
S of X equals
F
4.
dash of X
Right,
equals.
right. So I want you to get in the habit of doing this stuff, because if when I give you the question and I say F of X is equal to that, find the derivative, I only put 4x plus 5, it's going to be wrong. Because you have to say it is F dash of X that is equal to that. It's very important. All right?
So
Very
function of so you can just say the function of derivative X is 4x plus 5 or something like that.
No, you're not gonna say that. You're getting right. F dash of X is equal to 4x plus 5.
No, I mean that in speaking terms.
Oh yeah. The derivative is going to be equal to 4x plus 5. Yeah, if you're talking, you can say the derivative, right? But what I want you to do though is to get into the habit, because they won't give you the question only in F. I mean only in Y. They will give you in any other thing. When you move to calculus 2, they will give you a function in pi and in alpha and beta and gamma and then wonderful little symbols there. It doesn't matter what they give you in, just look at the function and work the function. All right. So you think you got it? What's the differential of that?
Oh. X squared.
So negative 1 square.
I don't think so.
Sir, 1 times. Sir, 1 to the negative to the X negative 4.
Function of it will be the function of derivative X to, let's see.
Sir, 1 times X to the negative cube.
Nope.
No, it won't be that.
Sir,
It'll be
F dash.
it'll be 3x, so it'll be it'll be
Minus
3x to negative 4 or something like that.
Sir, I said negative 4.
Yeah, that's correct.
What's all correct?
Oh wait, it was a positive. Christ.
So I think it's X to the negative.
My answer no.
Sir, I think it's
Sure, it's
F-
not negative 4, sir. To the negative 4.
No.
Negative 3x
squared. 3x to
Yeah,
the negative 4.
3x squared.
Yeah.
Is it negative 3x squared?
Yes, sir, because it's x times 3 times x is 3x, and then you have 3 minus 1.
Sir, negative
3 minus 1, because that is a positive 3, so negative 3 minus 1.
Okay. Hurry, tell them for me,
Just at the
please.
time I answer to the chat, sir.
3.
Hurry, what you got for the answer?
Negative 3x squared.
So I just redid it, and I think it's negative 3x over negative 5.
That's not what you said.
Sorry, over negative 4. I mean.
Some mistake as well. It said, I think.
3 negative.
Negative.
Negative 4, yes. That's it.
Negative 3 over x
3
over
x.
x4.
The answer will be function of derivative X
minus
is equal to negative 3x to the power of negative 4.
All right, good. All right, good. I did an exercise a while ago. That you wouldn't even know. Anderson, Erlington, Francis, Cook, Thomas, Crossdale, Rowe, Wint, Udu, Lawrence, Mendes, Brown, Lambert. The cat having a tongue. When they can't open them out and answer something and participate in the class.
Sir, I did
No,
answer.
Sir, honestly, the two confusing while ago, that's why I'm gonna bother say nothing.
I don't care where you get Michael.
Sir,
Anything
I
you get
did say x to the power -4, sir.
Did
I
you
did
say
say
that?
that. Yes, sir,
Okay,
I
well,
did.
I apologize, sir, if you said it. But what about the others? You did say something, Tom, I miss it?
Sir, we
I
don't spend
said
time
that.
to think.
Yes,
I was just working it out.
To be honest with you, because so much things me I hear and me I try to figure it out myself.
No,
So
look, you
Yes,
open and
sir,
say, Tariq.
same.
No,
Sir, I was
Tariq.
guessing, you know, sir.
Tell me. Tell me what you get. Me no, yes, you can listen with one ear what the classmates are saying, but me want to hear what Una said too.
sir, me I skip through my book and I go back to the notes and I look and I try to
Tariq,
figure it out. So,
Tariq,
to be honest. Yes, sir.
Tariq. Poor excuse. You know why? I
Right.
just went through the revision with everything that we did last class on differentiation. Talk truth.
That's true.
Yeah, that mean our payment of mind. So it comes back to the fact that in our payment of mind. So me now go buy that. Take out the lunch money for tomorrow.
All right, next question, sir.
Oh, you already
try to
know.
be the first. I'll try to be the first to answer.
Sovan, can you bless me in class tonight and let me hear how your voice sound, please?
Yes, sir.
Okay, thank you. Last class, you showed off for them for audio. I know you don't want to talk to teacher. Remember now, guys, it is going to be x to the -3. Anybody remember me saying that? It's x raised to the -3rd power.
Yes,
and then when the
I
difference,
remember now, sir. Yes,
you
sir,
remember
you did.
now? All right, no problem. There's no love lost in it because we're learning this stuff, but we want to learn quicker. So it's going to be x raised to the -3rd power. But guess what? I need to tell you a little secret right here. There are two things I need to tell you. So you're going to have, so I'm rewriting it here, from here to here. So I'm going to have x raised to the -3rd, and look at what I'm doing. The same concept is carried forward. -3 multiplied by the coefficient becomes -3, see it right here, so? And then I'm reducing the power by 1. -3 minus 1 is -4. -3 minus 1 is -4. But guess what? In big school mathematics, one of the things that we often do, the format in which they gave you the answer is the format in which you're going to give them back the solution. And this answer here could also be written as come on, computer, just make it a good little self. That answer could be written as no, as -3 over x to the +4. Talk truth.
Yeah, it makes sense.
Yes, sir.
Yeah, man. So because they gave me a positive index, I'm leaving my answer as a positive index. Besides, we never normally leave our answer as a negative index or a negative power or negative exponent, all mean the same thing. Then, sir, what if I just written my answer as -3 times x to the -4? Would I be wrong? No, you won't. You won't. But let me ask you a question. I'm going to ask Courage this question. Courage, you know what oxtail and beans and rice and peas, you're introduced to that kind of something in Jamaica yet?
That's rice and peas. I don't know the last one you just mentioned.
Okay, all right. So let us use chicken and rice and peas, all right? So you get a nice place of chicken. Latoya decides she's going to cook rice and peas and chicken for you, right? Because she may be able to cook and cook nice. So she cook a nice plate of rice and peas and chicken for you, and she plate it out nice in a container. And you go to a road and you see one bus and you run down the bus, but incidentally, run down bus in Jamaica here, but you run down the bus and you run down the bus and your back kind of shake up, and the food shake up. And when you open the food, it look unpalatable. Would you still eat it?
Yeah.
Okay, you're a girl of my heart, So I eat it same way. That's the point I'm making though. So it don't look so palatable, but it still can be eaten, is the point I'm making. So the -3, x to the -4 can be eaten, but it's not so palatable because the presentation not so good. But when Lottie did share the food now and put the little meat one side and the vegetable one side and the rice and peas on one side and one little slice of pear to the other side, this is it. This is now in a more presentable form because I'm leaving my answer as a positive index. Not that the one that can't eat, because me I wax it down same way. Me I box it down same way. You can't talk to me. So when it go in the belly, the same way so it look. All right? So that's the point I'm making. So even though it can be eaten, because it's already cooked and well cooked, it's just that. Dan. So you asked me a question earlier and I answered you, but I knew I was coming up to this because I was expecting this to happen. Here goes Dan. Was it Dan or Leon?
No, it was Tariq.
No, man, it wasn't Tariq, man. It was, anyhow, one of you asked a question about the F with the dash up top. And then I said to you that if you're doing the second derivative, it's going to be the second dash. Watch this. So this is my question. F of x is equals to x cubed. F of x is equals to x cubed. When I'm finding the first derivative, it's going to become f dash of x. And when I'm differentiating the first derivative, it's going to become, when I'm differentiating the function for the first time, it's going to become 3 times x to the second power because I'm reducing the power by 1. That's my first derivative. And if I did use y, this f dash of x is the same thing as dy by dx. From here, I can find me the second derivative by differentiating the first one more time. Watch me. 2 times 3 is 6, and I reduce this, it's going to become 6x. See that so? Boom, 6x. And this is now f double dash of x. So somebody asked a question, can't remember who exactly it is. Somebody asked a question, then sir, we couldn't just write, was it Crosswell? We couldn't just write the answer like that. And I said, no, you have to tell me it's a second derivative because I am not supposed to be guessing that, okay, the student went and found the second derivative. You have to tell me what it is that you find. All right? So the second derivative is going to be denoted as f double dash of x, which is equal to 6x. Or I could call it d squared y by dx squared, same 6x. So whoever asks a question, and I almost sure this is Daniel, whoever asks a question, f dash of x is going to be 6x. Yeah, man. D squared y by dx is the same 6x. But guess what now? I can ask you to find the third derivative. It means that I'm going to differentiate the second derivative one more time. And that now becomes f triple dash of x. F triple dash of x. And when I differentiate 6x, I'm going to get 6. And if I use y, it will be d cube y by dx cube. And I still get my 6x. So whichever format I use, I'll get the same answer. Tell me that you said that in Jesus' name.
Yes, sir.
So,
Yes,
all right. So, in regards to this, in regards to the derivative, what's the absolute lowest that you can go, in terms of finding out terms.
Any amount of terms, sir, that you want to go to? What is the fourth derivative, Crosswell?
It would be 0.
Why, Crosswell?
Well, at that case, since the third derivative would essentially be 6x to the power of 0, and anything to the power of 0 would basically be 1.
Give me a name for it, Crosswell. The 6 is a what?
No,
no, wrong C.
Constant.
It's a constant. Very good, son. Very nice. So the fourth derivative would be a 0. The fourth derivative would be a 0. Why his question is important? Some functions will have infinitely many derivatives. Some functions will have infinitely many derivatives. But there are other functions that will have a finite number of derivatives. This one is an example. Finite because you can count. I have a finite number of students in my class because I know how many students in my class. There's an infinite number of students in the college. We don't know how much in the college. So the finite number of derivatives I can find in this one will be the third. So the fourth derivative is 0. So is the fifth, so is the sixth, so is the seventh, because all of those are constants. Any questions?
Sir, I kind of understand. No. So I was saying that I kind of understand even though I never come class Tuesday. Sir, but this is
just imagine when you watch the video, you understand it even more.
It's not really hard.
It isn't. It isn't. All right. I'm moving into the power rule. Jesus, Father, me say, them teachers here, you see, them love to give you the easy something them and them build up confidence and look what Jojo say. Sir, it's not so hard and boom. The next question or something. Sir, you never done not like this before. Don't worry about it. Fret not.
Sir, I think I can get this in my mind.
All right. I'm going to give you 2 minutes, guys. I want to see how many of you think you can get this. Which part you get triggers? Go about your business. But just ask this. Yeah. Yes, Shantia, you got the correct answer. So you thought. 2 minutes. 2 minutes. 2 minutes. Stepping away for 2 seconds too. 2 minutes. Let me see.
So you never tell what the power rule say.
Answer. Okay, I see an answer there.
So
I got 8x.
You got an 8x?
Wait, what? Sorry.
8x plus 20, sir.
8x plus 20. Okay.
Sir, can I explain how you get the AX? How I get it?
I may hear you.
Okay. So basically, I multiply or I basically do in one step, apply the square all of the terms in the bracket. So what I get is 4 multiplied by x squared plus 20, right?
Wait,
So
shouldn't it be 25?
25, sorry. Right. So what I do now is to differentiate that, right? So I find the differential of that expression. So I multiply the two terms, 4 multiplied by x squared, and I get 4x squared. I just put 0 for 25, right? Okay.
Why?
Sir, because the differential of a constant is 0.
Very good. You understand why I asked you why though, right?
Yes, sir. Yes, sir.
Why?
Sir, because
I just want to see if you know why you put 0. Continue.
Okay, so basically you multiply the power or the exponent by the coefficient, and you get 8, right? So you get 8x to the 1 power, to the first power, to the 1 power, right? So you get 8x. Right, so it's F 2-stroke probably.
No, one time I differentiate. On 1 stroke, man. I one time I differentiate. When I differentiate it 2 times or 2 strokes.
Oh, okay, sir. So that means I have a first stroke. So all right, so f dash of x is equal to 8x. That's what
Anybody agrees with him?
Sir.
So that's what I did.
Sir, that's what I got to 8x.
That's what I got. Because when I saw the chat, sir, I saw things like 8x plus 20, and I was confused because I was saying to myself, it should be 25.
8x plus what?
8x plus 20. That was like one of the answers I saw in the chat, so I was confused.
Sir, is there anything we need to know about the power rule differently from the chain?
Absolutely. I deliberately not responding to your suggestion, utterly. I deliberately not answering that. So I'm seeing Courage 8x plus 20. Leon is saying x plus 20. Kamoy, it's saying negative 21.
So I'll say 4x.
And you're saying 4x.
Sir, my first answer was 4x. 4x. Sir, I'm gonna leave it at 4x until I can prove me wrong.
Okay. Courage, why you give me 2 answers? Which is the correct answer, Courage?
I saw the 8x the first time I saw it, I forgot something.
Okay. No. It's a good teacher-student relationship, you know. Because when I go on with the antics, I'm a cussing out. And then now, when I start participating in a class, and then I feel like me I teach something, and then I see people trying. Not all the answers are correct. There are 2 very interesting answers. One of them I don't ready to talk about yet. But then I want to have a conversation with you. I want to have a conversation with you, Dan. The conversation is, what if this were 2x plus 5 to the 12th power, Dan? What would I do?
Sir, that's a function.
This one is a function too.
Uh-huh.
2x plus 5 to the second power is a function also. But my question to you is, you said to me that you expanded 2x plus 5 times 2x plus 5 to get your 4x squared plus 20x plus 25. And I say again.
Right.
Yes, sir.
What if that were 2x plus 5 to the 13th power? What do I do?
To the what, sir?
To the 1/3 power.
To the 1/3 power. You mean 1/3?
To the 13th, 1/3.
That's a very weird way to say that.
Sir, I don't know how to go about that, but I would just.
You definitely can't use difference of squares in that situation because that would take too long.
Sir, can I explain to you how I got 4x?
How you got 4x?
Sir, what I did was to examine the question. That is the first thing. Sir, and then I look at the question, I was looking at the question and said like outside you're squaring everything in the brackets by 2. So what I did was 2 times 2x is 4x, and 2 times 5 is 25. Sir, the constant always equal to 0, sir. So what I did was leave it at 4x, and then I have 2 minus 1. So that means 4x to the 1 equal 4x. That's how I got 4x. Thank you.
Okay. You sound like a mathematics chef. You just cook up something a while ago, too. But guess what, though? Shanti, unmute for me, please. Because me like when students do big chat in a class, Shanti Boo.
Yes, sir.
I absolutely love your confidence. Tell me why you're so confident about it. What did you do?
Sir, I squared everything in that bracket. So when I use the factor up there, I times it. So firstly I times the 2x squared plus the 5 squared. So that would give you 4x plus the 5. So when I times that now by the 2, it would give me an 8x plus the 20.
All right. So me can see through, based on your argument, me can see through when you say you get 4x and you multiply by 2 for you get 8x.
Yes, sir.
But me can't say, oh, you get the 20.
Sir, 2, 5 is 10, right?
Yeah.
So you know the 2 is outside, and when I times it by the 10, you get a 20.
Okay.
Yes, sir.
All right.
I use we just open up like say 3 calculus log and put into function, and apparently the answer will come up is 8x plus 20.
All right. So guess what I have a challenge with? Not really a challenge, a concern.
Can't care about that.
So sometimes you guys do the mathematics. You get an answer. Dan was talking to me a while ago. I said, why? You get an answer, and I said, oh yeah, your answer is right. But how you arrived at your answer was by using an incorrect method. but it so happens that it worked in this particular case. Your method will break down because in other instances it don't work out. I will ask you, Shantia, the very question I asked Dandan. What if that were 2x plus 5 raised to the 13th power? Your reason right there would break down terribly. Terribly. All right, let's go. Ultimately, I don't come to your answer yet, because that is a special case. I have to deal with you specially with that one.
In regards to that question, sir. I wrote the function in the calculator, and the answer in regards to that is apparently 26. This is like the first derivative. In brackets would be 2x plus 5 to the 12th power. So
okay. If it was raised to the 13th power, that's what it's saying?
That's one part of the answer.
Okay, all right. Yeah, that's fine. But you see, what Sir Mark for Crosswell is its answer alone. So anybody want to put something in a calculator, that's fine. Just best believe that you get in 1 mark for the answer. So the question carries 10 marks.
Still trying
and
to
I want an answer. You won't be getting 10 marks. You'll be getting 1 mark. And guess what? And the steps must be plausible. Right? Let me tell you something. You see, the same pride that I take in teaching my class is the same pride I take in marking your papers. Let me do a new share. And just show you something because it's very important. What am I looking for? Mark papers, final.
So, Lashantia, Miss Clark, I am writing down the method that you explained. So, could you describe it to me again?
What 1 minute, Crosswell. 1 minute. I'll have her do it for you, but I just want to show you something. So this was an exam paper for calculus 1, I think. It was a calculus paper, one of them. Can you see the paper? Can you see what I'm showing you?
There's the
zoom
in.
Sorry, I have to zoom in.
The bodies inside, so
this is what the student did. Would have copied the work into a Microsoft Word document. Now, the mere fact that I saw this in the numerator, the student got a mark for it. The mere fact that the student says it's either this one or this one is the answer would have gotten a mark. So there are different points in the question that you must have. And the student was able to do the question, excellent, and got 4 out of 4.
Interesting.
The point I'm making is when I get a question like that, like this question here, the student had to do the second derivative. So doing the second derivative alone, I didn't give a mark here because the student would have got a mark up top for the second derivative. Can't find it. Would have gotten a mark for the second derivative up top, or wouldn't have gotten a mark for the second derivative because they didn't have to do the second derivative test right here. But the student chose to do the second derivative. So I wouldn't give a mark here because there's another method that could be used. So if the student did the other method, it means that the student wouldn't get a mark. So I don't give a mark for this piece here. But the student used the second derivative test and was able to get that. It's 3 out of 3, excellent. To that, 3 out of 3, excellent. Now in the last, remember now, the second derivative is 12x plus 6. In this part of the question now, the student had to use the second derivative. So I must see this 12x plus 6 and boom, bam, to get these marks, and the student got the 4 to 4. What's the point I'm making? There are several steps that the student has to go through in order to be able to maximize the mark on an exam paper. So those of you, and I strongly discourage you from doing that, because I know what is happening. You are going to fail the exam. You're going to fail the course, because when you come out and get the answers and you say, hey, pass calculus 1 with flying colors, you will have a guess coming, because it will be considered cheating, one, and your methodologies will have to be shown. All right, so that's just me sharing with you how it is that I mark your papers, or how your papers will be marked. But let's get back to this. What we know. So I'm using the power rule. And why I have to teach you the power rule is because if that question, in fact, was y equals 2x plus 5 to the second power, 2x plus 5 to the second power, the method that Ashantia described, that Dan described, and among others, couldn't work. Couldn't work. So watch me. Just like we did in the other examples, the power 2 is going to be multiplied in front of my stuff. So what I'm doing is considering 2x plus 5 as just my x. So the 2 is going to be multiplied as if it's multiplying the coefficient for the question.
Which is 1, sir.
And then the result is going to leave me with 1. So I'm going to have 2 times this 2 come over here. So boom, see it right here. So 2x plus 5, this is 2. It now becomes 1. But what is important, very important, that wouldn't be the end of the question. You have to differentiate inside the parentheses and times all of that function by the derivative. When I differentiate inside 2x plus 5, what is the differential of 2x plus 5? What is the differential of 2x plus 5, class?
So,
So that's why I multiply by this 2 right here. So recall, times 2 is obtained from the differential of what is inside the parentheses. You will always multiply by the differential of the inside of the parentheses every single time. You have to multiply by what is inside of the parentheses. The differential of the parentheses.
Sir, I'm curious to know how could we guess that methodology?
All right. And I didn't expect it to. That's why I said, I don't know if you were listening, that's why I said that I am going to speak to Arthur Lee separate and apart, because I have not yet commented on her response. This was Arthur Lee's response to me in the chat.
So it was 2x plus the 5. I didn't remember the 2. You have to multiply it by the 2. So that was what I wanted you to explain.
Right. So right. So I saw that. So what Arthur Lee has in the chat is 2 times 2x plus 5 to the first power. 2 times 2x plus 5 to the first power. Is when you Ashantia? What are you talking about? I talk to Ashantia?
No, sir.
Oh, all right, let's go. So Dan, you asked a very valid question, sir. Then all media should know that. Because I gave you the question expecting that you are going to go ahead and multiply. And when you multiply, you're going to get the answer to be 8x plus 20. So I wanted to play around with the class to see how many of you would recognize that you have to expand first before you differentiate. And most of you did. Some of you didn't do well with the expansion and end up with 4x. But a good number of you did well with the expansion and ended up with your 8x plus 20. And that's the point I'm trying to make. If you get something to the 13th power for argument's sake, you can't go do all of them something there and multiply 13 times. The exam got done. And the question only carry 5 marks, only 5 marks I get. So you have to go know the dark method.
Wait, sir, can you scroll back up, please? I want to see the rest of the statement.
No, before I scroll up. So let me give you the proof now. This is how you guys did it. So Dan, see teacher nice? Him no say this is how you were going to do it, Papa. So teacher showing you now. Lotto, you gonna sleep?
Calling me, sir?
Yeah, you gonna sleep?
No, sir.
Oh, you understand?
Mm.
That one they don't like. Not look so positive at all. All right. Leonie, all right? You understand?
Sir.
Hmm.
You can
Sir, when you finish doing this, I probably have a question.
So that the 8x plus 20 is the correct answer?
Yes, Papa.
So, that's what I got, but I didn't work it that long way like what you did it.
Like what I have on the screen now?
Yes, sir. I just times it up at the top there and got the answer.
In times what? What the times, Leon? Explain that.
And then I break it down and then.
No, tell me.
I don't
You don't know
know
where you're talking about. Tell me, where you do?
All right, so I times the 2 times the 2 in the bracket there, got the 4, then times the 4 times the 2, got 8, times the 5 times the 2, got 10, times it again, I got 20.
What the heck?
Yes, so I don't want to explain it, but I did it.
You know, that's the same thing that Ashanti is saying.
Expand
That's not right.
Sir, you know, so that way I just say, but
And that's what I'm saying to you. And it concretizes a point that I'm making. And I don't want anybody who got 8x plus 20 say, oh, my method works. Because I'm going to give you other questions and I guarantee you that it's not going to work like that. No, that is mathematical cooking. Don't work so.
Sir, then why? Sir, why
When
when
I'm
you cooking, I thought it was a good thing.
No, it's not a good thing. You cook the maths. All right, let's go. So the other method would have been to expand. You know you have 2x plus 5 all square. It's going to be 2x plus 5 times 2x plus 5. And this 2x times this 2x is 4x squared. Because in all what you just said a while ago, was it Leon who was talking to me a while ago? No. Oh crap.
Ashanti, sir.
No man, not Ashanti. Come on, was it you that was talking to me a while ago? Please,
sir.
Anyhow.
Yes, sir. I just said this is what I was doing, sir. What I missed up.
Is you talking to me, right? Come on.
Yes, sir. No.
Yeah. I was trying to remember who was talking to me. So come on. In all of what you said a while ago, you never mentioned anything about no 4x square, you know. You just said 4x. And anyhow you do that, you have to get a square.
Sir, 4x I put, sir. I didn't put the square.
That's the point I'm making. So either get zero right through the rest of the question and just 1 mark for the answer. Say this was a 5 marker, you get 1 out of 5, even though you answer right. Real talk. Let's go. 2x times 5 is going to be 10x. 5 times 2x is another 10x. And 5 times 5 is going to be 25. 10x plus 10x is 20x. Now I have my function in a trinomial form. I've successfully removed the parentheses. I'm going to go ahead now and differentiate. Since my function is in y,
Sorry, hold on 1 minute. Go back up
ahead.
go back right under where they have the third thing with 4x squared. So how you got those answers right there? Because I'm not understanding right there. So
2x times 2x.
Okay.
To give me 4x squared. And then the same 2x times 5 to give me 10x. And 5 times 2x to give me the other 10x. And then this 5 times this 5 to give me 25.
Okay, so I got it now. Thanks.
Nice. All right. So remember, if we are doing the question this way, we have to expand. But I don't want you to get into the habit of doing an expansion. This, I notice I put it as proof. I call it my proof. Because I'm not teaching you to do the question like that. It's just a proof. How I expect you to do the answer. You're going to have my 2. This is what the power rule says. 2 times the 2 right here, so in front of this. You're treating all of this as x. So you can write back all of this, reduce the power by 1, and then you're going to differentiate what is on the inside of the parentheses and then multiply it by it. So this is what Arthur Lee did. But Arthur never remembered to differentiate what is inside here to multiply by the 2. And so I have some notes here for you. We are required to differentiate inside the parentheses. To apply the power rule, index must not be equals to 1. To apply the power rule, the index must be equals to a number greater than 1. Must be equals to a number greater than 1. Agreed? How you feel?
Disappointed.
All right, never mind. Oopsie daisy. Never mind. This too shall pass.
All right, so this will be 4.
Sir?
Sir,
I think the moral of this experiment that you are running is that you're supposed to have an open mind and, you know, because your perspective may be wrong, even if you understand it well.
Absolutely. And even more so, Papa, is that sometimes you get your answer and you say, sure, you know, it in your pace or no my method works. And when you check a stop and you reach in a one corner, you recognize that you run out of ammunition and the enemies are moving in closer and closer and closer and closer, and you don't have any defense. So that's why I always say to you, now I hope you understand why I get so agitated or chipped when students don't respond to me in class. I want to hear you. Because sometimes you think that you get the answer and say, I don't have to talk because I'm learning, I understand, but your concept is wrong. Because quite a number of you got the 8x minus 20 or the 8x plus 20, whichever one, 8x minus 20. Quite a number of you got the 8x plus 20 rather for the answer. Quite a number of you got 8x plus 20. But guess what? When I when I'm having that conversation, I recognize that a lot of you are cooking. The expansion is not working. It just don't make no sense. Mathematically, it's not sound. Not sound. So this is why I keep saying to you, the ones in class that speak up are the ones that often pass the course, because guess what? Any misconception that they have, they are cleared up. The ones who believe that them know it are going to carry those misconceptions to the exam room, and you're going to fail the course. All right, do me a favor. I gave you a new question just now. I'm going to give you a couple minutes to work it, starting now.
I know. I'll move on near 9:30. Oh.
Dean, unmute for me, please.
Yes, sir.
So you're not planning to talk to me tonight?
Sir, I answered earlier, sir, but there was confusion, so you probably didn't hear me, sir.
All right, so it's when the confusion finish, when you talk to me here.
Yes, sir.
All right, thank you, Papa. All right, so I'm going to stop because Miss Lottie, thank you, please. I see you recognize what it is that you did, and I like it. So where you direct message
Moving away for a second to just grab a bottle of water, please.
Yeah.
Trust me, I need to do the same thing too.
Wait.
Yeah.
Wait, say you never want us to do the thing after that, sir?
No. We're not doing no proof. We only prove if you come here and teach you something. We not do the other part. All right. So I like the energy. 7 minus 3x. I like the energy. I am doing the question very quickly to see if I get the same answer like you. I'm not even going to put this right up inside of it because I'm not interested in the right up part again, yet again. 7 minus 3x. To the 5th power. Who got that? Anybody got that?
Yeah.
Yes, sir.
All right.
Sir, you see we get it, sir.
You see what I did? I did it in 3 lines. So you get the function, bam, this multiplied by this, just so, see just so. You reduce all of this by 5, by 1, you get to the 5th power. Then you differentiate the inside, you times it by that, boom, bam, bam, done. Nothing hard about it. Very nice.
I got it.
Yeah, man, most of you got it. Most of you got it. Most of you got it. All right. So that's the power rule.
You ready to stop?
We are going to be moving on to the product rule now. Here the DJ part now. The first times the differentiation of the second plus the second times the differential of the first. So the first times the differential of the second plus the second times the differential of the first. The first times the differential of the second plus the second times the differential of the first. Listen to how else I can say it, because sometimes I'll say it interchangeably. The first times the differentiation of the second plus the second times the differentiation of the first. So I can say the first times the differentiation of the second plus the second times the differentiation of the first, or I can say the first times the differential of the second plus the second times the differential of the first. Easy 1, 2, 3, differentiation done. It is the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first.
Sir? No matter how much time you repeat it, I understand. But I have a question though. The first means the first deviation of the expression. Is that what you mean by first?
Hold on there. It's 756. I'm coming to you, Dan. Joe, what kind of maths cooking you do here? Let me just address this, because I see something here in the chat. Look at what Joe did. Joe multiplied 18 by Joe multiplied negative 18 by 7. And she multiplied negative 18 by 3x to get negative, well, I don't know what she should have gotten positive 54. But you can't do that expansion because 7 minus 3x is being raised to the 5th power. So I can't distribute this negative 18 over this because there's a 5th power right here. So erase that for me, please, Joe. You can't do it.
Erase.
Thank you, please. Don't make that mistake. All right, let's go. Yeah. So it's the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differential of the second plus the second times the differential of the first. All right. Sir, no matter how much time you say it, me not catch it. All right, no problem. So here goes an example. Y is equals to 2x squared times 5x minus 3. Sir, but I just multiply the 2x squared over the 5x minus 3 and just differentiate it, sir, using a chain rule. That is plausible also. But sometimes the question comes and say, by using the product rule, blow out. It means that if I use any other rule other than the product rule, I'm wrong, because it specifically says to use the product rule, right? So in differentiation, there are several rules. Incidentally, we've gone through 4 of those rules already. The first rule we looked at last Tuesday, plus at the start of tonight's class, was the chain rule. And then we looked at the power rule. Now I'm at the product rule. The product rule says it's the first times the differentiation of the second plus the second times the differentiation of the first. Now, unlike inquiring minds, and Dan ask a question, sir, no matter how much time I say, you not get it. So when you say first, it means the first derivative, and it was a very close attempt. Not the first derivative, but the first term, Dan. So watch me. I want all of you to pay attention here now. Lottie, you back with the water yet?
Fair, I'm back.
First time, right. The first time.
Watch me now. Watch me. Watch me. It's the first times the differential of the second. Now, it is important for me to name them. I name my function. Even though I'm the teacher, I name my function. I call the first, and I call the second. I mean, I write down what is the first, and I write down what is the second. Because we now make no mistake. So watch this. The first, 2x squared, I write it back. Anytime I call the first, I write back what the first is. Anytime I call the second, I write back what the second is. So the first, I write it here so. Times the differential of the second. No, I'm differentiating 5x minus 3. What is the differential of 5x minus 3?
Yeah, it'll be 5.
To the 5. See the 5 right here in the bracket? 5. Plus the second, plus the second, I go right by the second. See? So every time I call the first, I write where the first is. Every time I call the second, I write where the second is. Right? Plus the second. See here, the second is 5x minus 3. I write it back, 5x minus 3. Times the differentiation of the first. I look on the first. When I differentiate 2x squared, what do I get?
4x.
4x.
See it right here, so 4x. Differentiation, don't write this in a blue. Differentiation ends right there in blue. The first times the differentiation of the second plus the second times the differentiation of the first. What is left now is algebra. What three? 5 times 2x squares is 10x squares. See that, so boom, 10x squares. Then I'm going to say 4x times 5x is 20x squares. See that, so 20x squares. And 4x times -3 is -12x, right? So. And 10x squared plus 20x squared can add up together to give me 30x squared. So we get 30x squared minus 12x. Because them give me, bracket form and bracket form, I'm going to put it back in bracket form and bracket form. Remember I said to you, any form them give you another question, that's the form them expect you to leave the answer in. Then, sir, if I left my answer as 30x squared minus 12x, would I get the same answer? Would I get it correct? Yes, you would. But the difference is, so what I'm going to have now is what is common here that is common there. I can factor out a 6x. And what is going to be left is going to be 5x minus 2. And the question ends right here.
Let's go again, please.
Yes,
Will
sir.
do.
Please, can go again.
The product rule says the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second.
Seriously?
Times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. Watch me. The first, let me write it back. See it here, so? Times the differentiation of the second. Now I need to differentiate the second. Differentiating the second, 5x minus 3 gives me 5x. Talk truth. Not 5x, but 5. Not 5x, but 5. Differentiation of 5x gives me 5. 5x minus 3 gives me 5, don't?
Yes.
Yeah.
And then the second term,
And then a plus the second.
Yes.
A plus the second. See the second here? Boom. A plus it times the derivative of the first. When I differentiate the first term is 2x. Yeah, it's 2x squared. And I differentiate 2x squared, I'm going to get 4x. See the 4x right here, so? Differentiation ends here. If you have everything right here, so like what I have in blue, you get most of the points. All right? And then now I'm going to say 5 times 2x squares or 2x squares times 5, the same difference. I'm going to get 10x squares. If I get 5x times 4x, I'm going to get 20x squared. And -3 times 4x is -12x. And 10x squared plus 20x squared is 30x squared. And if you leave it at the answer right here, so you get full marks for no.
But
little later on, you factorize the answer and the more you get. Question.
All right, so
go ahead.
All right, so since you bring up the fact that you want us to return the answer in the way the question it was worded, if a student were to do that, what would I say to you?
If a student what?
All right, so say you're marking a answer sheet, and a student wrote the answer in terms of how the question was written, like what you have in example 1, as opposed to someone who just wrote out the answer and didn't elaborate. What would that tell you then, sir?
It would just separate that student from the rest of the class. That student is truly understanding mathematics. Remember, mathematics is a language. It's a language. and how we speak that language. And this is why I want you to speak the correct stuff. So which is why John Dan said something about derivative, and I said no, term. Because when you leave my class, you're supposed to be able to subject verb must agree. It's a language and it is universal. So when you speak the math, it must be able to be communicated to effectively. Because if you don't speak it correctly, the man going to wonder what you talk about. Ineffective communication. So yeah, I want you to be able to, it tells me that you are fully understanding, and you know, I may give 1 mark for, if it's a 5 marker, maybe you get about 3 marks out here. So, and show me this, when you do the manipulation, you get 1 mark, and to group it, you get another mark. So this would be like a 4 marker. So you get a 1 mark to show me this piece, you get a 1 mark to show me this piece, you get a 1 mark to show me this piece. And if you do this piece, you get another mark, because I have to credit the student who would have done that. So if you don't show me the last piece, you then only get 3 out of 4. 3 out of 4. All right. The only way I'm going to know if you understand. Only way I'm going to know if you truly understand what is happening is unless you try that example for me. I'm stepping away. Try that example for me, please.
So sir, how much marks would you take off like answer? I'm curious to know.
How many marks based on what it is that you gave me for your answer?
Yes, sir.
Let me go back to it. I was actually looking at it and then
yeah, because I forgot. When I wrote my answer the first time, I remember he said to always put in context of the original question, so I factorized it.
well, actually, you're the only one Crosswell that gave me the correct. Ashanti, you pay Jojo no mind. You notice that I have not even responded to her. Don't pay her no mind. I don't know what is wrong with her. She needs to go.
The part, the expanding, you're supposed to, the second part, make it incorrect, right? Where you where you put the, like where you do the first derivative, where you put the 3x squared, that one, this so, yeah, this one, okay. Never do that. Me skip that step there.
Sir, would you deduct marks?
No, he wouldn't do that. No, sir wouldn't do that marks. You just write on people like say,
I like that student.
I can write second.
I like that student. Oh Lord, bless him heart, Jesus. I like that student, Lord. Try me and you'll see.
No, sir.
You know what? Try me. then ask her, do you deduct marks? Oh
So I want to
Lord.
pass the course, so that's why I'm asking,
Okay, yeah, and I like the attitude, Guess what? You have to laugh sometimes, because life get too serious, yeah. All right then. I'm gonna go through the question, but just remember, the race is not for the swift here. It's only for those who can endure and endure right down to the end. And this is what I was about to talk about. So I was going to commend, and I'm seeing Raji just made mention of it. What you can do is to see what it is that you have and compare how close you were to the final answer, and then work on the areas that would have prevented you from getting the actual answer. Your brain tired. Guess what? Think about the teacher that has to come up with all of them questions here, and to try and bring it across. Yeah, we know we're tired now, but guess what? Right about now, I would want to say class has ended, but we can't say it. Crazy, because at the end of the day, it's going to bite me when I don't finish. But look at me now, and that's fine. You may not be close now, but for sure, you can get closer. You can superimpose it, means they get the same answer. So some students, how they learn pretty quickly in class, get the information, and it stays with them. Others, which would include me, say there's something, I have a basic understanding of it, and know some if I go home now and go practice. You say me come back to class, you start the bright spot them, when me start answer question, them say, blow out. And we get so much right answer from our time brain. And when teacher move on to something new, them catch it, because them bright, them see it the first time and catch it. Me have to go home and practice it. So me come back to the class and teacher go through that again, me know it. So they are only a class ahead of me. only a class ahead of me. So I don't want the whole course to be ahead of you. Start working. All right, let me go through this. Let me go through this. I mean, no want nobody give up on me, you know. Oh, if me not give up on me, can't give up on me here. Real talk. All right, let's go. Matter of fact, that may be mischievous. Lambert, good evening, sir.
Yes, sir. Evening.
Are you understanding?
Yes, sir. I made a mistake while factorizing, but I saw where I went wrong, sir.
Okay, thank you, son. Tony Ann, good night. Tony Ann,
Yes, sir.
good night.
Good night, sir.
Are you understanding?
Yes, sir. And I've sent my answer in the chat, but you skip over me.
I skipped over you?
Yes,
Oh my
sir.
dear. Hold on. Oh, you actually did. You see where you went wrong?
Went wrong?
Mm-hmm.
I thought. Oh, you mean at the end where I'm supposed to have 12x squared and in the bracket? It's in the book. It's just I didn't send it in the chat.
No. I see you have 24x to the fifth minus 36x squared. But I don't see the final answer.
Yeah, and I'm saying it's in the book. I just didn't send it in the chat.
It's in your notebook, but you never put it in the chat.
Yes, sir.
Okay. Got it, sweetheart. Bless your heart. Thanks for being a nice student tonight. But do you put your one in or something too?
No, sir, not in the chat.
Listen to me now. May I have it out in a youth. Why don't you put something in the chat? You're not understanding it now. That's why I don't put anything in the chat. You're not understand. And you're not being honest to yourself. You're not being honest to yourself. Reefer, oh, you stay? Sharifa? Come on, how you stay?
Sir, I'm good, sir. I see where I went wrong, sir.
Okay. Then?
Not fully grasping the concept, but with a little more practice, I think I should be able to get it right, sir.
Okay, sir. Thanks for responding, sir.
Yes, sir. Tarek understand. Sure.
No man, Tarek look like him married him, man. Tarek. We have to rough up Tarek, man, and enough I don't know him just both way like a beige kite.
Yes, sir. Exactly.
Yeah, man. Same way, so that me like, man. Yeah. All right. So I think I've heard from my students for the most part. All righty.
Sir, ready for the next question now.
Oh, like so. You like want to say to me that you're me? Never mind. I still give it to you know. Make sure you get it right, you know. But do me a favor though. Let me just go through this one for those who missed this one. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. When I call the first, I write it back. When I call the second, I write it back. The first, boom, write it down. 4x cubed, see it right here. So times the differentiation of the second, I'm looking for the second and differentiating it. It's going to be 3x squared, see it right here. So plus the second, every time I call the second or the first, I write it back. Second, I write it back. x cubed minus 3. See to yourself, boom, times the differentiation of the first, a differentiating 4x cubed. 3 times 4 is 12, 12x squared. See it right yourself? Differentiation ends in blue. I fix her up now. Watch me. 4x squared, 4x cubed times 3x squared. 4 times 3 is 12. X squared times x cubed is x to the 5th. Recall, when I'm multiplying and the bases are the same, you're going to be adding your power, you're adding your index, you're adding your exponents. So 3 plus 2 is 5. So I'm going to have x to the 5th power. And then 12x squared times x cubed is going to be 12x to the 4th, 12x to the 5th. And 12x squared times negative 3 is negative 36x squared. You recognize the first two terms. When added will give me 24x to the 5th, as Miss TAB had it. And negative 36 squared is as is. And for the most part, I can see where you were getting what it is that the question was getting at. Congratulations again, Tariq. Very good. You make me feel like me I teach tonight.
Yes, I may I learn one.
Yeah. All right. Now go see if I'm ready now. Watch that. Hold that one for me, please. Lottie, I know you're tired, but
I'm
come.
here. I'm
Yeah.
here.
Yeah, man. Come. Start for me, please.
Sir.
Yeah.
So let's say when we reach to when we're breaking it down, and let's say we have to use a constant, or we have to use, we're not using like the ones that I worked before. I'd use the x squared, but if this one I'm not gonna use the x squared, that means I should divide the content, I should also divide, what am I term this now? Should the constant still be a part of it? The one that stands alone, should I divide that as well? I reach a particular point, but I want to know if I can break it down further.
I want to answer you, but I don't think I'm following you so well. Say it again.
So, sir, I have the answer that Courage have there. Yeah, that's what I have. But I'm saying, can't I use 2 to go into everything there, so, and bring it down a little further?
You press pause 1 minute. When I project the answer, you show me exactly where you're talking, because I'm challenged to follow what it is that you're saying now. I will correct there. What is preventing him from posting my answer?
Eric still at work.
I'm not getting it. I'm not getting it.
Lottie, I mean, you not get it, Lottie, but you not get it?
No.
All right, so it's the first
times
the differentiation of the second plus the second times the differentiation of the first.
Yes, I get that, sir.
What is the first, Lottie?
The first is 2x plus 1.
Great.
The second
times
is
times the differentiation of the second. When you differentiate the second, what you get? Aha, that's the problem. Differentiate the second term from now and tell me what you get.
Oh, and the first term may differentiate.
No, man. So it's the first, that means you can write on the first term, times the differentiation of the second term, plus the second term, times the differentiation of the first term.
Okay.
Tariq, how are you going with Brethren?
Yes, sir. My answer right now as you talk.
Sure.
Just give me 10 seconds.
Because you have big talk in the class and then you can't defend that. I don't understand you.
Well, I hope some answer right. Right, some answer there, sir.
All right, let me see it. All right.
I was asking.
Okay, AAB, I see what you have. Teddy, I see what you have also. So let me see who is closest. Let me see who is closest. Do I have my answer here?
Yes, sir, we get it right. Can defend my big talk.
Me say, Bedrin, me say anything you eat for lunch today, Tariq, eat it again every day.
Well, fruits me love this evening.
Bedrin, stop eat meat and start eat fruits every day.
Yeah,
every day. Every day.
So that's what I was asking you, sir, if I can use it.
Yes, AAB. I see what you're asking me now, and you are, I would give you 95% because you just needed to do the last part. You are correct, but you just need to finish off with the last part now. So, change that cube to a squared, Chedi. Yes, courage. I see your answer, but Lorks, man. Me go give a Jamaican bag juice and one Carl's bag juice and one banana chips, you know. Right, the last part for me, no, man.
So actually, also, when I reached that point, I was finding how to factorize this because I couldn't find anything that could go with into 12 and 2. I was just like, oh, let me just end it here. Because you said we should get the answer like we should get the answer like the question. So I was looking for two. Yeah.
Oh, you got 2 brackets, 2 sets of brackets. Got you. Crosswell, congrats. Hey, Shantia, eat lunch today. You can't tell me nothing more than that. And I talk about no flash out, you know, I talk about good food. Shanti Boo, congratulations. Congratulations. No, let me tell you something. I'm not going to do anything else. I'm going to send you some questions. I'm not going to do anything else. I just want to ask you, I have 6 minutes. I'm going to use about 3 minutes out of the 6 minutes and answer a question. What is the difference you believe when you show up in class and participate? What energy you think it has on the class?
Positive energy.
Yes. I'm gonna learn and write what we did a while ago. Me not ask you, I'm telling you, there was some levels of camaraderie and competition, and people felt comfortable posting their answers to the chat. And for the whole class for 3 hours, and I was watching. Lambert, you have not posted a thing. Badu, you have not posted a thing. Wint, you have not posted a thing. Ro, I can't recall you posting one earthly thing. What is happening? What is happening? But anyhow, for those of you who have participated and show up, you showed up well. Very well. And I congratulate you. If you keep up the good work, trust me. On a can't fail. Now, it's just one person who sent me a direct message. She said, sir, you said something about mid-semester, and I recognize the rest of you don't come to me and say, sir, why are you continuing to teach? Aren't you supposed to stop teaching because we have a mid-semester exam? None of you, with the exception of that one student, is honest enough to say, sir, we're supposed to be getting an exam. Why didn't you remind me that we're getting a mid-semester tonight?
So it's not tonight, sir. Remember last week when I said, and you say praise something another. It's not tonight, sir.
No,
Monday,
you
when
get
I
that
said
wrong.
it, you said thanks, but of praise of something.
No, Lati.
I must pray myself.
Lati, no,
yes, sir.
man. No, Lati. Hold on. All right, hold on. Did I say that the mid-semester was tonight, guys?
I never heard it.
Yes, sir.
No, sir. When
I thought it was
class
next week.
on Tuesday, sir, I said to you, sir, when you said exam Thursday, and I said, is it this Thursday or next week Thursday? And then you use a phrase, a Bible verse. But the Bible verse have something to say. We must be lucky. It's not Thursday.
Okay, all right. Well, anyhow, so Lottie me don't know how you manage, because guess what? It was supposed to be tonight. But Spirit of the Lord says to me, give them grace and make them do some more work, because I went on Edico and I didn't see much movement. No. Grace is something that sometimes she get tired and she needs to rest. Come next week, you're getting a test. Oh, blow that rhyme. Rest and test. Yeah. So be ye prepared. That's what I'm going to say. Be ye prepared for next week.
Thursday. Next Thursday.
Next Thursday, yeah.
Okay, so so it's the same limits. No, nothing over into the differentiation.
No differentiation of this type. Just differentiation from first principles. Chain rule, product rule, power rule. Yeah. Just up to differentiation by the limits. Everything else before we start this topic here. All right,
Sir,
guys. I
I have
enjoyed
a
my
few
class
questions,
tonight.
but I'll send it in the group for the kind of lost with the explanation part because of a mad mister. I'm not gonna lie. With them,
Okay.
yes, I mean, reach out.
No problem. Tariq,
sir?
anything you need to send a recipe, Tariq, to the other students in the class so that come Tuesday we can just run. I'm proud of what it is that you do. Yes, Dan, go ahead.
Well, the trace recipe is just following it because of.
Oh, that's good.
Well, me so glad you said Arthur Lee said it earlier, so I don't know what else to say. Honestly, I don't know what else to say. But anyhow, yeah, Dan, how you stay? You good?
Yeah, yes, sir. I just need to point out something. And by the way, sir, Rajay had submitted his answer for example 2. Just putting that out there. But sir,
Okay.
yes, sir. But for
I'm
example
sorry,
3,
Rajay.
yeah. But for example 3, I have canceled out the +2 and -2, and I think that's where my downfall was. If you scroll up here, you will see what I'm talking about, referring to.
Do me a favor. Find out where Tariq buy him fruits them so you can go to the shop here. Because you shop a supermarket, him go downtown go shop. All right?
Exactly.
Well, very good, guys. Very good. And for those of you who go
So
ahead,
can
go
you
ahead.
just go up a little more so I can
Sure.
scroll up top?
Sure. Tell me to stop.
Right there, sir. Put more.
Okay.
Then you can see the final answer.
Yeah.
Okay, that's okay.
Right, good. So I'm ending. I'm just gonna say to you, those of you who you notice what happened? Not everybody who posted their answer got their answers right, but guess what? They were bold enough to post their answers, and that's the spirit of the class. So congratulations to those of you. To the rest of you, Mr. Bodu, if you come next class, may I give you one question? You alone are going to do another class, and you can do it. If you don't come class next week, any day come class, I'm going to do the question myself. You have to participate, Papa. Dane.
Yes, sir.
We're not going to fall out, right?
Pardon?
We're not going to fall out, right?
No, sir.
Okay, thank you, sir.
Yes,
You
sir.
have yourselves a wonderful rest of the night, all of you.
Thanks, sir. Same to you.
Take care. Come on. Take care.
Same to you, sir. Bye.
Same to you, sir.
Take
Good
care.
night,
Talk to you.
sir.
It's a heart.
Sir.
Yes, Papa. Yes, please.
Yeah, just a correction, sir. I did post an answer, sir, but it was wrong.
Okay, Mr. Lambert. I'm happy that you posted something, and I apologize, Mr. Lambert.
Yeah,
but I want to hear more of your doors, Zidian. You hear me?
Yes, sir. Regarding this question, sir, I came with the wrong answer. I realized that I made just a lapse in concentration where I differentiated, what was it? I differentiated the second part incorrectly.
Okay.
Yeah.
But you see your error now, right?
Yes, sir.
All right, good. As long as you can pick up. Very nice.
So is it Tuesday or Thursday? Tuesday or Thursday for the exam?
Thursday.
Thursday, okay then, sir. All right.
Thursday, yeah. Come on.
Yes, sir.
Will you show up next class?
Yes, sir.
Okay. Thank you, sir. Sovan, will you show up next class? Okay, I guess not. Rajay, will you show up next class? Show up more, Rajay, for next class?
Hopefully, sir.
Oh, hopefully. I'm going to drop you from a class. That's what I'm going to do. Anyhow, have yourself a wonderful rest of the night. Whoosh! Out of here. Yes,
sir.
Papa.
I know why I got mine wrong, sir. You see in the second line, like the 2, I put 2x in, sir. So that's why I got it wrong.
Right here, sir?
No, sir. The second one, in blue, the end part, sir. 2x.
Oh, right here, sir.
Yeah, I put 2x there instead of 2.
Oh.
I did that for the other one as well, and that's why I keep on doing the same thing.
All right. So you know what you need not to do now, right?
Yes, sir.
All right. Let's go. All right. Take care, guys.